This video is about atomic radius, which is the radius of an atom. This is the graph of atomic radius versus atomic number, and it shows the trend across the periods and groups. As you can see by looking at lithium, as an atomic number increases, it keeps getting smaller and smaller. This is because of the stronger pull, because more protons are in the nucleus. But once it gets to sodium, it adds an energy level, which actually increases it, and you can see the jump from neon to sodium. And this is present for all the elements as one extra energy level is added. There's a jump, and the atomic radius actually increases.
So, we can measure the atomic radius by first observing the diameter between two bonded atoms and their nuclei. And then from there, we are able to cut that diameter in half and get the calculated radius of the atom. But first, we must know that there are two types of atomic radius. There is the van der Waals forces atomic radius, in which the atoms are more touching each other because the attractive forces are weaker. While there's also the covalent atomic radius, in which things like metal atoms are pulling on each other with stronger attractive forces, which causes a reduction in the observed atomic radius.
So, as you can see, it's very hard to determine atomic radius, and it's not definite because the electron clouds, there's infinite area that an electron can be located. It's based on probability, so the chance of an electron being somewhere is never zero. So it could technically be anywhere around us. There's two different types, as Stefan said. There's the van der Waals method, and though they have a weaker attraction, the two atoms, so they're more touching each other and they're not overlapping per se. So that's a more accurate representation, whereas the covalent method, they're overlapping more.
Alright, so the periodic trend of the atomic radius is that it increases as you go left, and it increases also as you go down. The reason it decreases as you go right is because there's more protons in the nucleus, which pulls the outer electrons more, so it decreases the atomic radius. And the reason it goes down and it gets bigger is because there's more energy levels or orbitals, which increases the atomic radius.
Another pattern seen is that as you move down a group or column on the periodic table, the atomic radius increases. This is because as you move down the table, the elements have more electrons and therefore more energy levels. These extra outermost orbitals or energy levels are shielded by the inner orbitals, so they have a smaller pull by the nucleus.
So, the atomic radius, as we mentioned earlier, is the measure of the distance between two atomic nuclei, divided by 2, since it's a radius. And there are some difficulties with this, such as the fact that, according to the Heisenberg uncertainty principle, we cannot know for sure the exact position and momentum of an electron simultaneously. This means that the electron is in superposition, and it can be difficult to tell where exactly it is. But generally, going across a row in the periodic table, the number of energy levels remains the same. So that is not what changes the atomic radius. It is the fact that going left to right, there is an increasing number of protons in the nucleus, which increases the pull that the nucleus has on its electrons. And this can be measured in electronegativity, which is why, going left to right, the atomic radius decreases, and also why electronegativity and atomic radius are inversely related to each other. And another criteria that is important is that the two atoms must be the same size or element to find the atomic radius.
Oh, we love chemistry. Ionization energy. atomic size and affinity. When you think of an atom and its radius, listen close, you just gotta trust. Get out your table of elements and follow these rules and you'll benefit. There's 2 parts that you need to know. Number of protons and electrons show the size of the element at hand. If you know how to relate them, you'll understand. Group 1 are the orbitals, and the farther you go down, the radius grows, cause electrons and protons are increasing, filling more shells, but you wait and see. The radius decreases from left to right, cause electrons with more protons, they hold them tight. They pull real close and decrease the size, and then it jumps down to the next alkali. Ooh.